So in the previous two videos, we have learnt about how sound waves are longitudinal and some of the important properties of the sound waves. In this video, we'll be talking about the speed of sound. So if you do like the videos of Easy Physics, please do subscribe to the channel. Let us continue with the video. Speed of the sound, some of the facts and some numbers that you should remember. That's what your examination also expects you to do, right? The speed of the sound is 330 meters per second in air. So that's a number you need to remember. It's a general knowledge based of information, right? Speed of the sound in the light is 3 times 10 to the power 8 meters per second. Both of them are the speed in air. Please do remember these numbers, very, very important. Please do it. Questions like this, questions on these numbers come straight away in your exam. Questions like what is the speed of sound in air? It is a straightforward question which comes in the exam, and then you have to write down the number. Even if you are writing the speed of the sound as 300 meters per second, 310 meters per second, 320 meters per second, or 340 meters per second, any which one of these, all of them are the correct answer, right? So anywhere in the range 310 to 340 meters per second is taken as a correct answer. Sound, if you see, compare the two numbers, much slower than light. So we see the lightning much before we see the thunder sound whenever there is a thunder and lightning storm. So lightning is seen first, sound is heard later, and this is a very common sense logical based kind of information that I'm sure that you know already. Alright, so how do you measure the speed of the sound? You can do a small experiment as shown in the picture here. Not so difficult. You need to use a cymbal. So cymbal is a musical instrument. As you see, this boy is holding, it produces a very loud sound. So that's the usefulness of this instrument, because it produces a loud sound which can be heard to a very large distance, right? So you need two people for this. You and a friend should stand on the opposite sides of a field at a measured distance apart. So you and your friend can stand at a measured distance apart, quite far away you can stand, because cymbal produces a large sound, and the friend will be, or you can be here even if you are very far away. You should be far away from each other as much as possible, but within the sight of each other. You should be seeing each other. It should not be that you are standing in a forest where there are a lot of trees in between and you cannot. So you stand far away, but make sure that you are seeing each other. So what are you going to do? Use stopwatch to time the interval between seeing the impact and hearing the sound. So as soon as one of the person is banging the cymbal, as soon as you see the other person banging the cymbal, you start the stop clock. And when you hear the sound, then you stop the stop clock. Because seeing will happen immediately. The light travels very fast. Seeing will happen immediately, but the sound will take some time to reach you. So you start the stop clock as soon as you see the banging action taking place, and you stop it when your ear hears the sound. And then you can work out the speed of the sound in air using this simple formula for speed, which is distance over time. So you'll see that your answer would be somewhere around 300 to 350 meters per second. So this is a simple experiment. Similarly, experiment was conducted to calculate the speed of the sound in water, and this was first conducted in the Lake Geneva in 1826. This experiment was done in 1826. So let us understand what was done in the experiment. As you see, two boats were taken which were far apart from each other, many kilometers far apart. You produced a sound under the water. The bell which is producing the sound is under the water. Why? Because you are calculating the speed of the sound in the water. And the detector which is detecting the sound is also under the water. This detector is detecting the sound. So you are also producing some flash lights. So how this whole system works, let us understand point by point. The bell is stuck with the hammer, also which causes the gunpowder to ignite at the same time. So this flash that you see here, it is like a gunpowder, maybe like a pistol which is producing a flash. So the bell and the ignition happens at the same moment. Important point. The ringing of the bell and the ignition of this gunpowder is taking place at the same moment. What happens next? On seeing the flash, the observer, this person is the observer who is 14 kilometers away, he starts the timer. So as soon as he sees the flash, he starts the timer. Why does he see? Because of light. Light travels almost immediately, instantly, because speed of light is huge. So you can say that the timer is started immediately. Alright, what next? The observer here stops the timer when the sound is detected by the trumpet under the water. So when this detector is detecting the sound, then this observer is stopping the timer. Alright, so you got, so some important data was noted down. A timing of 9.8 seconds for a distance of 14 kilometers gave the speed of the sound to be 1430 meters per second. And if you see, speed of the sound in water is more than the speed of the sound in air. This is one of the properties of the sound that we have learnt in the previous video. Alright, so this is how the speed of the sound can be calculated. Two experiments we have seen in this video. In the next video, we'll be talking about echo, and we'll solve some of the examples question on understanding how echo works. Thank you.